Hello friends, welcome to my YouTube channel. In this video, I am going to discuss the continuation about the morphology of viruses. I already discussed in my previous video about the morphology of viruses, in which I discussed about the nucleic acid, the protein code, that is the capsid, and about the enveloped viruses. I told you that the capsid is responsible for shape and for the symmetry of viruses. So in this video I am going to discuss about the shape of viruses. Shape of viruses. Okay. Most of the animal viruses are spherical in shape. Remember that most of the animal viruses are spherical in shape. But there are some exceptions. So we are going to discuss about the exceptions. What are the exceptions? Bullet shape is rabies virus. Filamentous shape is Ebola virus. Filamentous shape, Ebola virus. Shapes and viruses. Bullet shape, rabies virus. Filamentous shape, Ebola virus. Brick shape, pox virus. Space vehicle shape, adenovirus. And wheel shape, rotavirus. Rod shape, tobacco mosaic virus. Tobacco mosaic virus. So, bullet shape, rabies virus. Filamentous shape, Ebola virus. Brick shape, pox virus. Space vehicle shape, adenovirus. Wheel shape, rotavirus. And rod shape, tobacco mosaic virus. Now discussing about the symmetry of viruses. Capsid is also responsible for the symmetry of viruses. There are three types of symmetry: icosahedral symmetry, helical symmetry, and complex symmetry. Icosahedral symmetry or cubical symmetry. The viruses which are having the icosahedral symmetry, they have a rigid structure. Such viruses which are having this icosahedral symmetry, they are rigid structure. Viruses that are smaller than 50 nanometer may appear spherical under electron microscope. Remember, the viruses which are smaller than 50 nanometer, they appear as spherical in electron microscope. Now seeing the examples of the viruses which are having the icosahedral symmetry. All DNA viruses except the pox virus and most of the RNA viruses have icosahedral symmetry. All DNA viruses except the pox virus and most of the RNA virus have icosahedral symmetry. Okay. Now going to discuss about the helical symmetry. helical symmetry. Capsomeres in helical symmetry, they are like coiled surrounding the nucleic acid in the form of helix. The capsomeres are coiled in the form of helix, okay, and giving the helical symmetry. The viruses which are having the helical symmetry, they are flexible, and the viruses which are having icosahedral symmetry, they are rigid. Example of the viruses which are having helical symmetry is few RNA viruses. Only few RNA viruses have this helical symmetry, which are flexible. Example, myxovirus, rhabdovirus, filovirus, bunyavirus. Myxovirus, rhabdovirus, filovirus and bunyavirus have helical symmetry. Pox virus is having complex symmetry. Third symmetry is complex symmetry. We discussed that except pox virus, all DNA viruses have icosahedral symmetry. Pox virus neither have icosahedral symmetry nor helical symmetry. It has complex symmetry. Example of complex symmetry is pox virus. Now going to discuss about the size of viruses. We discussed about the shape of viruses. We discussed about the symmetry of viruses. Now we are going to discuss about the size of viruses. Viruses are extremely small, vary from 20 to 400 nanometer in size. I already explained in my general properties of viruses video that viruses are small in size. They are 20 nanometer to 400 nanometer. As they are small in size, we need to use electron microscope to visualize them. Smallest virus. This is the most important point. Which is the smallest virus? Which can be asked in your NEET PG or next exam. Smallest virus is parvovirus, which is 20 nanometer in size. Largest virus is pox virus, which is 400 nanometer in size. Most important points. Size of the viruses can be determined by the electron microscope, which is the best method, ultracentrifugation, and as they are small in size, they can pass through membrane filters of different pore size. Size of the viruses can be determined by first one, electron microscope. I discussed this point already in the general properties of viruses. Please watch this video, that video if you do not watch. Best method. This is the best method for the determination of the size of viruses. Best method to determine the size of viruses is electron microscope. Second is ultracentrifugation. Third is they can pass through membrane filters of different pore size. Genomic size. Now going to discuss about the genomic size of the virus. Retrovirus have the largest genome, whereas the smallest genome is found in the hepatitis D virus and hepatitis B virus and parvovirus. See, which is having the largest genome? Example, the virus which is having the largest genome is retrovirus. The virus which is having smallest genome is the hepatitis D virus, hepatitis B virus and parvovirus. These three viruses have smallest genome and largest genome is present in the retrovirus. And one more important point about the RNA viruses is they are classified as positive sense RNA viruses and negative sense RNA viruses. RNA viruses are positive sense and negative sense. So let's see what is positive sense RNA virus mean. Positive sense RNA virus is the virus which can act directly as messenger RNA or mRNA, and the virus which cannot act directly as messenger RNA or mRNA, they are known as negative sense RNA viruses. If the virus act directly as messenger RNA or mRNA, then it is a positive sense virus. If the virus cannot act directly as not act directly as messenger RNA, then it is a negative sense RNA virus. Okay. So this is positive sense RNA virus and negative sense RNA virus. All RNA viruses are the positive sense RNA virus, but there are some viruses which are negative sense also. So let's see the examples of negative sense RNA virus. Example, filovirus, rhabdovirus, arenavirus, bunyavirus, and orthomyxovirus, that is the influenza virus. So these viruses have the negative sense RNA, whereas all other viruses have positive sense RNA. In my next video, I will draw a table about the classification of all DNA and RNA viruses. I will be making one table and explain you about in detail and in easy way about the DNA and RNA viruses. If you like my video, then please share this video with your friends and please subscribe to my channel and press the bell icon. Thank you.